Welcome to the last section of Chapter 6, Molecular Formulas, which is kind of strange because we've sort of already done molecular formulas back in Chapter 4. So more of the point is on this video is how we're going to get from an empirical formula to the molecular formula. That's the key today. First, I'd like to remind you of what a molecular formula is. See, a molecular formula is what we've been doing all along. It's like the real deal. I'm going to write that down. Real deal. You know, like back in Chapter 4 when we did nomenclature, and I said, hey, what is the molecular formula for glucose? Remember that? Yeah. Well, there's the actual chemical formula for glucose. It's kind of beautiful. I think so, but I'm a geek, and at every single one of these points, you find a little carbon atom. So, C6H12O6 is the way we commonly write glucose, and your biology teachers will be so happy you remembered that. But that is the molecular formula. What we did on the last video is we found the empirical formula, and if you recall, the empirical formula for this is the reduced form of this. So we would have CH2O. This would be the empirical formula. This one over here is the molecular formula. That's the difference. Oh, look, I even had it on there and I didn't know it. Surprise! All right, there's hydrogen peroxide. The molecular formula, the real deal for this thing, oh yeah, that's the molecule, it's kind of pretty, is that. That's the formula. But if I were to reduce it and find the empirical formula, I'd have gotten ho. Yeah, ho. The goal of this video then is to show you how we get from the empirical formula to the molecular formula. It's so easy. First thing is, there's the empirical formula. I assume you know how to do that. Then you're going to need to find the molar mass of the empirical formula. The molar mass. What is the molar mass? If you're going snap, well, I'm really just asking you, how much does this guy weigh in terms of grams per mole? Yeah, go to the periodic table. And then you get that number. Okay, now what? Well, the second thing is hugely important. See, you got to be told the molar mass. Oh, look at that. It's got to say molar. I missed that. Okay, you got to be told the molar mass. If you're not told the molar mass of the molecular formula, you're kind of foobarred. You got to get that. Somebody's got to tell you what it is. It'll be somewhere in the problem, and you got to find it. Oh, look, that's the molar mass of the molecular formula. There, I gave it to you. See? So what are you going to do with this information? Is no biggie. You got to find a ratio of the two molar masses. The ratio of the two, it says numbers, maybe the two molar masses. And if you're looking for a formula, it's always going to be the molar mass of the molecular formula divided by the molar mass of the empirical formula. Just like that. See? And that number is 6. Groovy, man. What are we going to do with that? Well, that is our multiplier. We're going to multiply each one of these subscripts by 6. So the molecular formula, the real deal, is C6H12O6. And that's all there is to it. Okay, this problem is pretty straightforward. We have been given the empirical formula. Oh, that's great. So we know that the empirical formula on this one is P2O5. Probably should have given you a minute to read the problem. Yeah. So why didn't you take a minute, pause the video, and actually read through the problem? Okay, good. So the compound has a molar mass of this. So this, ladies and gentlemen, is the molar mass of the molecular formula. Probably the hardest part with these problems of figuring out what you got. So here I have the molar mass of 283.88 grams per mole. So I'm going to make a line over here saying molecular formula equals. So we are after this. Can you find this? Can you find the molar mass of the empirical formula? Well, pause the video and see if you can do it. 2 times 30.97 plus 5 times 16. So I end up with 141.94 grams per mole. What are we going to do with these? Well, remember, the multiplier is found by taking the molecular formula's molar mass and dividing it by the empirical formula's molar mass. So 283.88 divided by 141.94. Okay, so 283.88 divided by that last number, 2. That's my multiplier. So what do I do with that? Well, I'm going to multiply this and this by 2. So the molecular formula becomes P4O10. That's all there is to it. This problem asks us to put all of the concepts together. I mean, the whole shebang chapter concepts all in one problem. Pause the video, read through the problem. What I like to do is I like to get rid of all that word crap and just focus on the important information, which is this important information. Well, the first thing we want to do is we want to, do you know? Okay, well, I want to assume that I have 100 grams. If I have 100 grams of this substance, then 71% of 100 is 71 grams. And that becomes grams, and we're good to go. So what's your first step? To finding the empirical formula, because that's the first thing we're going to have to do to get to the molecular formula. Well, I got to find the moles of each one of these guys. So 71.65 grams of chlorine, 35.45 grams of chlorine for every 1 mole, and that's going to equal 71.65 divided by 35.45. We get 2.021 moles, and I'm following sig figs here, of chlorine. Now let's do the same for hydrogen. 4.07 grams of hydrogen, 1.008 grams of hydrogen for 1 mole. So 4.07 divided by 1.008, we end up with 4.038 moles of hydrogen. Now do the same thing for carbon. My hand's going though. 24.75 grams of carbon. Whee. Okay, 2.01 grams of carbon to 1 mole. 4.75 divided by 2.01, and we get 2.061 moles of carbon. Okay, so the rule is, find the smallest one and divide. Well, if I divide this, I'm going to change my pen color just to make things more interesting. Good green. Okay, divide that by 2.021, I get 1. Divide this by that same number, 2.021, and what do I get? 4.038 divided by 2.021. Oh, I put a plus sign in. Okay. Oh, I get 2-ish. It's 1.998. That's pretty close to 2, and I know if I divide that, I'm going to get 1-ish. Ladies and gentlemen, we have just found our subscripts to the empirical formula. So the empirical formula becomes, I'll find my pen. Okay, so we end up with, I'm going to start with chlorine, because they're not chlorine, carbon, because that just seems to be the right thing to do. If you don't put them in the correct order, I'm not going to get twisted, I promise. So I'm going to do C1, not writing the 1, H, sorry about that, my hand's going numb. Gosh, it's tough getting old. 2, and chlorine 1. All right, we have now found the empirical formula. Yay! But we're not done. We still have to find the molecular formula. Well, to do that, we have been given the molar mass of the molecular formula. And I apologize that on your packets, I just wrote grams. I didn't write grams per mole. That's a mistake on my part, which I will later remedy. But I have that. So I have 98.96 grams per mole of the molecular formula. What do I do now? Well, if you said that we have to find the molecular formula for the molecular formula, in order to find the molecular formula, I need the molar mass of this guy, you are right. So let's do that. 12.01 plus 2 times 1.008 plus 35.45. And we end up with 49.48 grams per mole. Okay, so how are we going to do this? We need to find the ratio of the molar mass of the molecular formula over the molar mass of the empirical formula. So 98.96 divided by 49.48, I'm going to guess that's going to give us 2. And it does 2. So our molecular formula, we're going to multiply this 2 by each of these subscripts. So the final answer, C2H4Cl2. We are finally done with this problem. This problem, I strongly suggest you really pay attention to this problem. Yeah, you really should. So take a moment, read through this, and see how well you do on your own. Those are the 3 that are given to us in the problem. I've seen a lot of students try to solve the problem with those 3, but that reading thing got you again, because oxygen is also given in the problem. Well, but there's no percentage for oxygen. If you recall, the maximum percentage you can have on any of these is 100. So if you add those up and subtract that number from 100, you will get the percentage of oxygen. Now you're ready to find the moles of each one. Well, when you do that, you should have found that many moles of carbon, and that many moles of hydrogen, and that many moles of nitrogen, and that many moles of oxygen. Easy, right? Now what do? Yes, you're right. You divide by the smallest. So I'm going to divide each one of these by this number. So I end up with 4 carbons and 5 hydrogens and 2 nitrogens and 1 oxygen. What do you do with those? Those are your subscripts. So there's my empirical formula. Wow, we're almost done. We just need to find the molecular formula. Now what I see a lot of kids do is they just guess because they can't remember this step, and a guess is better than nothing. But you do need to have the molar mass. The molar mass of the molecular formula. And that was also given to you in the original problem. So we got to find the molar mass of the empirical formula. And that's that. The only other thing you have to remember is this, that the ratio of the molar masses of the molecular formula and the empirical formula will give us the multiplier, which in this case is 2. So I'm going to take this number 2 and multiply it by each one of these subscripts. Oh yeah, and that one. And there's your final answer for my favorite molecule, caffeine. Boy, this chapter's had a lot of stuff in it. We started off with chemical composition. By that, we looked at the mole and how big was the mole and what a mole meant. And no, please, it's a conversion. That 1 mole of anything is going to equal Avogadro's number. And it could be Avogadro's number of anything. Most typically for chemistry, we use atoms or we use molecules or, as your book likes to use, formula units. Ha. Okay, so let's see. Oh, then we learned how to calculate molar mass, which was grams per mole. You need to know that when I say molar mass or you read the words molar mass, it means grams per mole. Now we can do all sorts of conversions back and forth. A lot of times we don't even care about how many. It's the grams to mole conversion that is the most useful for chemists. Then we looked at percent by mass. From that, we were able to do empirical formulas, and lastly, molecular formulas. Now, if you can do all of that, you should be good to go for the test. And up next, I'm going to cover the study guide. Have a great evening.